Okay, so out of all the things we did, I think that was an important problem, okay? This one here? 3 and a negative 2. Here, this one here, this could be written as 1 over 3 squared. So I put because the negative says always put it in the bottom. So, and then I execute it. 3 times 3 is 9. Yeah. Yeah, it's a little thing, but they're a little bit treacherous. If you don't go slow, you tend to stumble. Now, on an exam, by the way, on the Scantron exam, you'll have, just so you know what's going on, what to expect, this would be choice maybe A, right? What would choice B look like? Yeah, there would be a 3y squared. I'm going to try to confuse you real good. X to the 6, maybe y squared over 9. I'm going to get creative like that, just like you get creative, okay? Because I know the kind of mistakes that you're going to make. So when you look at those, this is not like the big dumb My Math Lab questions where sometimes they're real obvious. I try to be not treacherous, but if you're going to do things a little too quickly, I'll make the choices here look very, very close to each other, and you need to really pay attention, okay? What I'm trying to tell you is it's going to be very difficult and some of the problems on the test for you to reverse engineer them, because you won't know what piece to reverse engineer. It kind of forces you to do the problem, which tests your mathematics. That's what I'm trying to say. Okay. Uh, 461. Let's practice this. Sometimes people goof this up too. And it's a simple example of just how to FOIL. For this section that we're going to be tested on, we're going to spend a lot of time finding roots. That's one of the SLOs, student learning outcomes, finding a root. Well, in order to do that, I need to know how to factor. Well, so I need to know my way around something like this. Now, this would be really, when you see what this is, it's hard to see how it would factor. But when we put this together, this is the opposite of factoring. We're just foiling, right? So minus x times this gives me a positive 2x squared. Minus x times this gives me a positive 4x. Minus times a minus, positive 4x. And minus 2 times this, positive 8 equals 2x squared plus 8x plus 8. Now, if you factored that, you would not necessarily get this because these negative signs can be pulled out to the front. Yeah. It's a little bit tricky, a little bit deceitful kind of problem. But I just wanted to make sure you understand that don't get yourself tripped up. If you see something like this, you should now be able to just see, oh, I just foiled that. The first thing with the second thing, no problem. No confusion, right? It foils real easy, just like anything else. No intimidation. For our purposes, what we're going to be doing is factoring things like this. Not so much doing foiling, because I'm assuming you all know that and you followed that. That was simple for you. Okay. If we have time, I'll just keep doing problems, but I want to get through these the key problems for sure. Okay, in section 1.2, so we're all about finding roots, meaning factoring, setting things equal to 0. So here's a problem, and I want you to complete the square. You're going to need to know how to do this. Somebody already started this problem. They made a little bit of a mess of it. So what's the first thing I'm going to do if I'm trying to find the roots? Yeah. Yeah, put it in a standard form, right? Don't keep it in this form. Let's get this x squared over here plus 4x minus 21, and since you're positive x, positive it's okay? I'm just checking to make sure I wrote it down right. Okay? Well, if I try to factor it, yeah, I guess I could factor it, couldn't I? Yeah, 7 and 3. So you know where you're going with this, but let's use the square root method though. Now that I've got it in this factored form, what's the square, the completing the square, what does that mean? This problem could be done another way. Yeah. Not C, it's I'm going to key on this number here, right? So it's going to be 4 over 2 squared equal to 2 squared equal to 4. And that's the magic number that I'm going to add and subtract. When I add and subtract, I can get away with this because I'm essentially adding nothing to this equation. So this is going to be x squared plus 4x plus 4 minus 4, and I just shuffle the minus 21 over. Okay? So this piece right there, I've really added nothing. Okay? What I've done is I forced this to be a perfect square. That was the whole idea. So this, I know I can factor this using this number. It's going to be x. You always keep the positive number. X plus 2 squared. I know that because I designed it that way by using this form. Okay? Then this minus 4 and this minus 21 are kind of dangling out there. So this is really a minus 25 equal to 0. Now I'm getting ready to solve this. Okay? So the next step here is x plus 2 squared. Take the 25 over to the other side. What do? Square root both sides, right? Now be careful when you do that because this is momentarily a definition. This is really an absolute value. That's the definition of an absolute value. And when I get back this x plus 2, I should put a plus or minus here. Yeah. Mm-hmm. Yes. So this x plus 2 now has a plus or minus. I'm not going to write it here. I'll write it over here. Minus plus what? 5, the square root of 25. Now I'm getting ready to solve. X equals minus 2 minus or plus 5. That means x, I'll call it x1, could be minus 2 minus 5. x2 could be minus 2 plus 5. This is minus 7, and this is plus 3. And if you stare at this for a minute, you could have factored that, right? You could have factored that if you stared at it for a minute. Yeah. Because I'm going to ask you to do that. Okay? So when I give a problem like this, I'm going to tell you factor it, and use the square root method. And you'll have some choices, you know, like what would be a choice A? Choice